use my personal.
Yeah, I started recording, bro. You can start.
Cool, cool, cool. So it'll be like conversationalist or like how you guys
Yeah,
just talk?
yeah. Basically, it's a conversation type, like how we do with the work, like what are the challenges you faced. So, as a part of this, we have to talk about machine learning, basically. So, machine learning course. So, what are the models you're working on? Like how you work with the data? Like what are the struggles you face when you like? What are the things you do to improve the efficiency of a model or something like that?
Okay, what specific industry, right?
Um, Not specific industry. So basically, it's like how like whatever we're learning, right? So how
Mm.
that it will help us in the industry. So that's the basically like what we are looking for here.
It actually depends on. So you guys are doing data analytics, right? And
Yeah.
it's specific to like machine learning only, like pure machine learning, right? It's,
Yeah.
I mean, this view context is machine learning
Yes.
and how machine learning algorithms are applied in the real world. That's
Yes.
the context of this study, right? And you guys want to go how deep, like as you guys want to talk about specific machine learning, or you just want me to just give an example of like what we used in the past, like in my previous video. So I'll just talk about, and then you can ask me questions related to that, like what kind of performances we decided to go on with, like what I
Okay.
all those like metrics used in machine learning algorithm.
Okay.
Uh, yeah, actually, so data science in general, it's become a very vague term now, right? Like everybody is talking about AI specifically after ChatGPT. Uh, like the multi-mix model algorithms have become so crazy now. So everybody started using it. Pretty sure you guys are also using ChatGPT, right? Yeah. So data science in general, it's a vague term, but it's mostly consist of statistics, where you need like different kinds of measures in the statistics, like p-value, r-value. You use stat model specifically in Python if you guys have used it to do any basic machine learning algorithms. But in general, a machine learning algorithm depends on the context or the problem you're trying to solve because there are like so many algorithms. It depends on the use case. So my role, so I'm a data scientist. I used to work for this company called Eternal, but now I moved to become a data science consultant in this company called CS. Um, yeah. So uh, in the past, I've been working on data engineering. So processing the data, cleaning, visualizing the data, analyzing the data, and building features for machine learning models. That was my initial role. You know, in data science lifecycle, you have multiple um, steps. So initially, you get the data, you pre-process and clean the data. So that's the first step you do in data science, right? So
Mm.
you need to make sense of the data. You just can't put everything in a machine learning model and ask it to predict. So you need to format that data. So that's where data engineers come into the picture. So in general, see data science, you have like three basic job roles, like data engineering, machine learning engineers. So data engineers, engineers, and then data scientists or research scientists per se. So they are the one. So research scientists are PhD background holders, like generally PhD in statistics, PhD in AI, PhD in machine learning, or PhD in some mathematical quant background.
Okay.
And then machine learning engineers are basically software engineers. But they should also have a little bit of statistics experience. And I think pretty much computer science friends, you guys would have studied stats at some point of time. Not as deep as how research scientists do, but you guys should have basic understanding of statistics like mean, median, mode. I mean, they're quite basic, but you
Yeah.
should know much more than that. And then so I spoke about machine learning engineers, I spoke about research scientists or data scientists, and then data engineers. So I am basically a data engineer because I studied like data science though, but did not do PhD. And generally, you who I work with are like PhD holders who are research scientists, who build like crazy machine learning algorithms, like neural networks, or you can say GAN, which you guys were reading about, all this multimix model, or based on Chat GPT, which is NLP. It's been like crazy these days. So that's what research scientists do. But what I data engineering side, which is the first pre-processing and cleaning the data. So, and building feature engineering. Also, I've built few basic machine algorithms like regression, SVM, classification algorithms, but not reinforcement learning kind of algorithms.
Okay.
So that's the context. Um, yeah, and then any specific questions you guys have, we can take off.
So in this concepts, like in this course, we are learning about like basic algorithms like linear regression, logistic regression, SVM, and we also got a little bit glimpse of transfer learning, reinforcement learning, everything. So do you anyway use these kind of models, like not as that way you're working on big models, right? So neural
Mhm.
networks and everything.
Yeah,
So anyway, use these kind of small, like these are not small, but these naive
basic,
models, yeah, basic
yeah,
models.
basic models. See, initially you cannot build a neural network.
Okay.
You start somewhere from basic algorithms. See, these days, explainable AI has become a new term, like XAI. I'm not sure if you guys have heard of, but
Yeah.
see, so everybody wants like any when you predict based on the accuracy, a layman term who wouldn't understand from the client's perspective because they don't know what is machine learning algorithm.
Yeah.
They're not from statistics background. So you need to build basic algorithms which you can explain to a layman term. Generally, they say you have to build or start building algorithm which you can explain for a 5-year-old kid.
Okay.
So you cannot start building neural networks all of a sudden, but initially you do some research. It's all about research scientists, basically. So in the beginning, have, you have to build like SVM, linear regression, basic stat models. At the end of the day, either regression or classification or I think it depends on supervised learning, unsupervised learning, or you're clustering the data. So that's the basic context where you want to use your machine learning algorithm in what kind of prediction you're planning to do. So, so yeah, you start with SVM or logistic regression or linear regression. And this one, even research scientists do all this, but it's helpful if data engineers can also learn that basic machine learning model building so that you can, because you're the one who's pre-processing the data and doing featuring. And the features, you have to implement these features are going to be using models. So you need to try and test out, right? So you're building machine learning algorithms which are quite basic in nature. I wouldn't say basic because linear regression, all these algorithms have been using in the production now.
Okay.
It doesn't it's not like basic, but neural networks it has like too many layers in between. It goes through, if it's much more complex, it's too difficult to explain for a layman term. So I would
Okay.
say with very basic regression algorithms. And I think now, at least even after ChatGPT took us over, I think we all should move in that direction. So at least know basic algorithms, at least in the data science perspective. I would say you should know basic machine learning algorithms.
And continuing that question, right? So you're saying like the model should be easy enough to understand, like from a 5-year-old or anything. So is there any situation, anything that, for example, the client may not know what is machine learning, right?
Yeah.
So any situation that you had to explain these kind of technical terms to the non-tech people, like how you did it?
Yeah. See, you have to use your tools and skill set. Like for example, I mean, explanation is one thing, and telling them that your model is accurate is another thing.
Yeah, it'll be
So
hard.
yeah, it'll be hard. So see, explanation, what you can do is you can do the architecture, like you can specifically say or visualize the data. Like for example, if you use Tableau and all, so you know what data you're analyzing the data basically, and you're looking at the prediction. Like for example, let's take a wild example. Like you're predicting the house price. So up in New York now. So it depends on if you have a 3-bedroom apartment, you have $5,000. That's just an example. and then you have 5 bedroom apartment, and it's $10,000. So now you have features. Now you can tell them from the past. So what you can do is you can show them historical trends of the data, and you're still not sure that in the future it's going to be like that. So all you're doing is predicting, but using science as a picture. So you can specifically talk about like what formulas you used, show them in the past which machine learning algorithms worked, and how accurate was your model. And when you split the data, you do training and testing, right? So
Yeah.
what you do is you can do validation, separate data set. So you have train, test, and validation. And what you can literally tell them is you've only trained on the trained data set, and you've not even used test data set or and validation data set. And validation is like the data set which has not been ever used in training your machine learning. It's like basically a new data coming into machine. And then you can show the accuracy of that. So that's explainable. But if we have to explain what an algorithm is in general, then I think
It'll be hard.
it'll be hard. But you can say yeah, it depends on what background the client is. But if it's like a 5-year-old kid, then it's difficult to explain though.
Okay.
Like, but that's the first test. Or in interviews, they generally ask these kind of questions. At least when I interviewed, they literally asked me to explain logistic regression to a 5-year-old kid. Like, how would you do it? What I took as an example was, like, for example, um, like your father wants a shirt, and he wants to categorize buying a shirt of small, medium, or large. So if you take a photo of the shirt to a machine learning algorithm, it will tell you what size of your t-shirt will you fall into. So it's basically predicting, are you a small size, um, or a medium size, or a large size. So you are seeing that kit, this tool or this algorithm will help you choose the size of the shirt for your father. I mean, this is the example I took, but you guys can have different examples.
Thank you.
So I have a question here.
Yeah.
So you just talked about you guys do for the accuracy you will do the training, testing, validations, but so how would you like really ensure that your model is trained enough, and how would you measure its accuracy, and how will you do its evaluation?
Uh, See, there are layers to your question, but in general, so you do train, test, and validation. And now just you look at different metrics. Like, for example, what algorithm you are using, there are different metrics. Like if you're using classification, then you have F1 score, you have precision, you have recall. You look at the true positive values and the false positive values. So when you do, like, for example, this is very classic example of predicting if that patient has a cancer or not. You look at the false positives, right? So it doesn't mean that false positive is not a good, valid example. Or for example, let's say you're predicting the spam of an email, and your data set has very few spam emails out of all. So here it comes what metric you specifically choose to determine if your model is worthy enough to be put in production. And to answer your second question, there are different metrics. We generally use like ROC curves for logistic regression, precision, recall. F1 score is quite good. This is for classification, and then for linear regression or regression algorithms, we look at the root mean square errors. Um, and also you can look at like how important your features are. There is a term called recursive feature engineering, where after you build the model, you can look at which features were important. And then you can literally go and dig yourself in, like why your model predicted for these features and why are these features important. Or what you can also do is, I mean, I did in my past, you cannot plot data which is more than 4-dimensional, right? Like for example, in Tableau, you can use color, size, shape, x-axis and y-axis. So in general, 5-dimensional data you can plot most of the times. But now you have billions of columns you've been using in ChatGPT. So you literally cannot explain that algorithm or a problem to a small layman term. Or you can also identify how accurate your algorithm is. Even I have used ChatGPT, Sometimes you can ask very basic questions to that algorithm, and you say that's wrong, it will correct itself. So you cannot completely go along with that, but I would say, yeah, go with the metrics, go with your intuition, look at the data, split, look at the features which were important, and then see why that model predicted only for these features, and you yourself select few rows and make a sense of the prediction, like why it predicted only this. Try to change the inputs to that machine learning and test it out.
Hey,
Yeah, sorry, go
so
ahead.
sorry. So I think data collection and feature selection are the toughest tasks. Other than these two, what are the other challenges which you usually face in solving the problem?
Um, like other challenges in the sense, in the whole data science life cycle, I would say the most difficult part for now, data collection has become easy. Like 5 years ago, 10 years ago, everybody was nobody was collecting data. Only like few companies like Google or Facebook or YouTube would have been doing that. But now, past then, they have realized that how important data is going to be. Like I joined my engineering in 2011, and Microsoft started working on these data science terms or big data in 2009 or 2008. So they literally worked for 10, 12 years, and they started collecting data back then. So they look for like long-term 10 years. So data collection was tough back then, but in the current context, I would say data engineering is like the key for a machine learning algorithm to evolve, because you need to. Nobody wants to do that housekeeping data, right? It's tough. Data engineering is tough. I mean, see, research scientists, data scientists, it's tough too. I mean, they are the one who are researching on your data and choosing the best algorithm for it. But then you're the one who is, I mean, you in the sense, data engineers are the one who are actually getting the data from different sources, putting that all together, joining them. You have different data types. You have text data. You have voice, video call data. You have to make sense of a lot of data frames. So I would say data engineering is the toughest, since I mean I'm a data engineer more than a data scientist. So I would say data engineering, feature engineering is more tough. So, I mean, if you ask this question to a research scientist, probably he would say this data scientist building a model would be so tough. Um, but in this context, and also now machine learning operations has become a too big thing. Like everybody is talking, because everybody is building machine learning algorithms, but nobody knows how to put it in production, keep them running for every day, because you need to build a whole pipeline, right? Like for example, you have data coming in, you're doing transactions every day. You need to collect the data, process it, put it in database tables, and then you have a machine learning model which takes that input. You're training that machine learning algorithm once a while. You need to look at how that model has been performing, because your data keeps changing. Right? When the COVID came, your whole data metrics and the features what we developed. Like I am a data scientist in the healthcare domain. When we build basic machine learning algorithms, it all worked pretty properly. But then when um, COVID hit, there were a lot of other seasonality and trend which completely changed the sales and the prediction of a doctor. So I would say a lot of different roles are complicated in the different sense. But for you guys, I would say start with data engineering. That's pretty good, so that you will know the nitty-gritty details of how data is managed and munched and cleaned. But if you guys are from research background, then I would say go ahead with data science. I mean, research scientists, research domain. That's pretty interesting too. But yeah, you're stuck in front of a computer for a long period of time.
So, extending to your answer,
Yeah.
um, uh, how do you like really approach feature selection when you are building your machine learning model?
Sorry. What were you saying?
So,
Sorry.
yeah. So, how do you approach feature selection while you are building your machine learning model?
Uh, See, one thing I spoke about feature selection was like recursive feature selection. I mean, I've used that. Um, it depends. Do you guys know about like dimensionality reduction, PCA, principal component analysis? Like, have you guys used that? But it, I mean, yeah, if not, but I can just quickly say you can use like p-value, t-statistics value. I'm not sure if I have to talk about this in so deep, but in general, you look at like when you build a machine learning algorithm, you have different importance given to each feature. So you can basically analyze the output of your predicted data and then see how much or which features were important in that prediction. So like, for example, let's say you have y is equal to mx plus c, right? It's a basic straight line equation. And you have the y which you're predicting, and then you have x which are different variables. So amongst all the variables, top five which are very now ask me for this machine learning algorithm, or if you ask like a skiller or very uh, famous machine learning functions which are built in Python, you have different functions specifically to know the feature importance. So they will give you directly. Now, if you do much more than that, like for example, if your model is too complicated, let's say you're doing like generating image, then you have like maybe thousands of columns. So in that, now you don't know, first of all, your model is too complex, right? The y is equal to mx plus c. Now you have x in the range of to the power of n. So now if you want to reduce that, then you differentiate it. I mean, you do differential equation on top of it. I don't know if I should talk about this, but you generally differentiate, right? Like when you have, like for example, in the neural networks, also it's pretty straightforward. When you have more complex algorithm, you apply differentiation on that. So the x to the power of n gets reduced and multiplied for n into x. So what you generally do is you have 1,000 columns now. You need to reduce that dimension. So there are tools like principal component analysis or dimensionality reduction, where what you generally do is uh, there is a term called matrix multiplication. So you have like 1,000 columns. So you have 1,000 vectors basically. You're trying to capture all those 1,000 columns of data in 5 columns. So you're transposing your matrix of 1,000 columns into 5 columns. I mean, isn't that amazing? Like you're literally reducing the dimension. So in the interstellar concept, he said like space time and there is another dimension. So it pretty much goes in this domain itself, like in the physics domain. A lot of economics physics comes into picture. That's why it's too fascinating to be a research scientist, I would say, because you're literally playing with dimensions of data in general. But yeah, I mean, coming back to your question, uh, recursive feature elimination, looking at the feature important. If your model is too complex, then apply dimensionality reduction, principal component analysis. Um, and specifically, if you ask me, then regression, you can do an L1 regularization, um, L1, L2 for regression. For classification, I don't recall on the top of my head, but these are the ones which I used and in my job roles. Good question, though. Sometimes I keep losing the question and I keep talking about, so please let me know if I'm talking about. So, yeah.
No, many inputs and we are getting with that. So, like if as a very basic learner to this domain, so if you have like any problem statement if you are given, and then you need to approach that problem. So how you will break down that, and how will you approach that problem? That first, of course, the feature engineering would be done after cleaning your data.
Yeah. Mhm.
And as you have already mentioned that what you are using, apart from that, how you decide what models we should build for that particular problem, suppose for that problem, like how you really decide which models would be apt for solving this problem.
Yeah, so it's a good question because this is more of a data engineer than data scientist. Because, see, first thing is if you identify a problem, let's say you have everything starts with a problem. You need to have a problem statement in any given context. Let's say if in the machine learning world, let's say for example, um, you're predicting the I'm into healthcare domain, so you're predicting uh, how when the doctor is going to be available for a patient to go and see that doctor. So that's the problem statement you're trying to solve now. So when or you can make a visit to him and patient so that the doctor will be available at that specific point of time. So what you could do, so this is the problem statement. So you need to literally define clearly what is your problem statement, what problem you're trying to solve. You identify the goals, that's the goal. And now you do reverse engineering. So now you know what is the problem you're trying to solve. Now you come back and see, do you really have this data? Like, first of all, do you have that target variable which you're trying to predict? So here you're trying to predict the time the doctor is available in that hospital, right? So you need to know the times in which doctor has been available in that specific clinic or hospital. So you look at the past trends of that doctors or the hospital data, and specifically you look at when the patients visited. So do you literally have a historical data of patients visiting the doctors? So that's the first problem statement. So you go back and now you do the gathering of the data. So if you have data, you have data from different sources, you can get all that data, pre-process it, um, collect that data, and you explore and visualize. So that it all comes down to data science life cycle. You clearly define the problem statement, you see you have the data in your system, gather and pre-process and collect them and put all of them together and make them. Um, and your question is the second question, right? Like, how do you decide which models to use? So guys, what generally in our company we do is the data engineers when they hire data engineers, they're also looking, as I already told you guys in the beginning of the call, that you need to have some experience of building basic machine learning algorithms. Not from scratch, but using sklearn or using H2O or using Keras or any of these libraries, so that when you do pre-process and clean the data, you will know how much worthy of a job you've done. Right before giving that data to a research scientist, you need to just do that basic understanding of how important or how good the data you have prepared. So for that, and also this will help for you because now you can, let's say you have like 5 linear regression algorithms you want to use. You want to use stats model, you want to do linear regression. In linear regression, you have L1 regularization or L2. You have lasso. I think you have so many of them. You want to apply gradient descent. So there are different techniques, different parameters you want to tune. So in that, what data engineers generally do is they have like 5 algorithms which are used on the same training data set. Now you get that data, put it for those 5 machine learning algorithms, look at the output of each machine learning algorithm. So you're basically analyzing the data of the machine learning algorithm's output. And you join the input data with the output data of a machine learning model for each model. And then you see which model performs better. And generally, this is not for the complete data set. What folks generally do is, if you have 1,000 rows of data, they literally split like in uh, from 1,000, they would use 100 rows for linear regression, another 100 rows of different algorithm. So it goes down to like the one input row to the level of different models can be used. But that's too complex and it's too crazy of a problem to solve, but folks have done it. So, but yeah, I would say automate the input data when it gets passed to machine learning algorithm, do cross validation for each machine learning algorithm. And then out of those 5, obviously you will have some parameters which you need to tune to decide which algorithm is the best. And then once you get somewhere in the real world accuracy, then I think you can go ahead. And then research scientists, of course, they have this upper hand and they'll go dig deep and tuning the parameters more specifically to that problem. But I would say the approach would be this, at least what we've been following in the company.
So as you're talking about the skills, so anyway, we are just about to enter this field of machine learning, data science and data engineering. So what are the most important skills we should possess, like, so that we'll be good in the field?
Importance Important skills you said, Kishore?
Yeah.
Uh,
So like maybe knowledge of like I should have a knowledge of these things that will be better for me.
See, one thing is if you're talking about technology's point of view, um, um, to be a data scientist, right? That's the question. Like to be a data scientist, what are the skill sets you need to possess?
Yeah.
Yeah, like about the background, I told you like computer science or I don't know. It's become. I've met people from economics background. I've met people from philosophy, being data scientists and research scientists, right? So it's too tough because a lot of people who've read that economics, econometrics, people who've studied commons, they're all data scientists. But I would say you need to be good in philosophy, I think, in general, because the boss who I report to who loves philosophy. And I think I also like philosophy in general because my mother has done BA in philosophy. And I feel a lot of commonalities between the scientists who come from philosophy because they generally understand the behavioral economics behind that data. Like specifically in the marketing field, we look at the consumer segments, we look at how people spend money on what products, and then so you're basically identifying, like for this example, if we talk about predicting the doctor's availability, we do much more than that in healthcare. Just to more examples, people get scared like what kind of algorithms you have built, but yeah, the skill set is too varied. But for most people, like most of the people come from computer science background, so you need to know basic coding. Like Python is like the key now. It was R back then, but now Python. Uh, in the data engineering world, and everything is on cloud, so I would say you should know like SQL. SQL is the bread and butter. You cannot escape SQL, and SQL involves a lot more imagination than research scientists, I would say, because you're imagining you're joining like 100 tables and you need to know all the columns, and you're like the dictionary of machine learning algorithm, right? Like for example, if a research scientist wants to use specific column, you should know the definition of that column, how it is used, and how it is pre-processed. So from the data engineer's point of view, yeah, SQL and Python. From data science, if it's data science, it's a vague term. A lot of people come into picture. So, but in general, Python, SQL, this is all about coding, statistics. Um, Statistics is the bread and butter for data science, for research scientists. And then you need to know about machine learning algorithms and AI. So machine learning is part of AI, right? So I would say discrete mathematics. That's like the craziest subject. Like finite automata, it all connects to that. But discrete mathematics, AI, uh, Python, Spark, and what else? And just one visualization tool like Tableau or and yeah, these are all the one thing. But then also one more soft skill you need to possess is when you explain it to a client or a layman term, you should be pretty good in explaining complex terms to layman. That's one of the key important soft skill you need to have.
Got it. Thank you.
What else? So you guys all are into data science, like data analytics, or
Like we are like all in data analytics, but we have no choice. Like for now, we have no idea. We're looking into like anything is fine, like data engineer, data science.
yeah, it's too tough for you to directly become a data scientist. But these days, people are been hiring because you need that roles and too many of the gaps there. Data science is tough, right? Because you need to understand the data, you need to know the philosophy behind what you're trying to predict, and it's fairly new. So, but yeah, I would say good luck for you guys. I mean, I choose what I did was it was so difficult for you to become a data scientist. Everybody wants an experienced data scientist. Nobody wants like a junior data scientist who wants to just come into picture and play around with research scientists. So I went the background through data analyst. So I initially applied for data analyst. I worked on my SQL skill sets, and then I applied for a role for data engineer or data engineer slash data scientist or data science architect. there's so many terms now, like so many different job roles you guys can approach. But yeah, but good luck for you guys.
Thank you so much, bro. Thanks for your time.
Yeah. All right. Cool. To wrap it up then. I'll
Thank you
thanks.
so much. Nitin.
No problem.
Thank you.
Good luck. Good luck.
Thank you.
Thank you.
Thank you so much.